Greetings to all. Welcome to our channel that is Food Tech Network. This is Parvesh Rana. Today we are here one of the most demanding topic that is refrigeration. We know temperature plays an important role in maintaining the quality of stored food products. If the temperature is high, then reaction rates will also be high and the quality of food products will be deteriorated. And if temperature is lowered down, the reaction rate will retard and then the quality will be maintained. So it is also said that reaction rate is reduced by 1 by 2 if the temperature is decreased by 10 degrees Celsius. So importance of lowering the temperature is very high, and one such method to achieve that lower temperature for our food products is refrigeration. So first of all, we'll see some brief introduction about refrigeration, that what is refrigeration, what is the need of refrigeration, and what is the market scenario of refrigeration. So what refrigeration actually is, it is a process of extracting heat from a confined space in order to drop the temperature. तो हमारे घर में भी रेफ्रिजरेटर्स होते हैं, तो उसका पर्पस क्या है, ताकि हम फूड को स्पॉइलेज से बचा सके। एक फूड प्रोडक्ट हम बाहर शेल्फ पे रख दें और एक फूड प्रोडक्ट हम फ्रिज में रख दें, तो जो फ्रिज में पड़ा हुआ प्रोडक्ट होगा वो ज़्यादा फ्रेश होगा और वो ज़्यादा देर तक टिका रहेगा इन कंपैरिजन टू जो शेल्फ के ऊपर होगा। और रेफ्रिजरेशन में या रेफ्रिजरेटर में होता क्या है, वो हमारे फूड प्रोडक्ट से हीट को निकाल लेता है और उसका टेम्परेचर ड्रॉप कर देता है। So usually we might have seen the temperature of refrigeration is 1 to 4 degrees Celsius. So what advantage do we get? So there microbes will also not grow and reaction rates will also reduce. Like if the temperature outside is 40 degrees Celsius and at refrigeration we are able to maintain 0 degrees Celsius, then almost by 2 times the reaction rate will be reduced. So now what is the need of refrigeration? So we have already talked some of the needs, that why refrigeration is needed. So we can achieve food preservation. Obviously, if reaction rates will be slower, then enzymatic deterioration will be lesser. So we will achieve the food preservation. Then food is also kept fresh because there is no enzymatic deterioration, there is no browning of food products, there is no other spoiling, there is no non-enzymatic brownings, so the food also remains fresh for the longer period of time. Then microbial attack is also reduced. So except for cyclotrops, we can reduce the attacks of mesophiles and thermophiles. So mesophiles need temperature greater than 10 degrees and thermophiles needs greater than 37 degrees. So their attack is also reduced. And then we can use refrigeration in the combination with some modern scientific methods to achieve more preservation of the food. Now we saw what is the need, what is refrigeration, and now what is the market scenario of refrigeration. So in 2022, globally it was valued at US dollar 19.73 billions, and compound annual growth rate is 4.4% from 2023 to 2030. And in India, it is valued at 4,602.6 millions, and compound annual growth rate is also expected 10.2% from 2023 to 2031. So now we know basically what is refrigeration, what is the need of refrigeration, and according to market, what is the importance of refrigeration. So now let us see how, so refrigeration do have a refrigerant. So how we are going to select that refrigerant, now we are going to have a look about it. So how we will select it and what are the examples of some refrigerant we will see. So first of all, we'll see what is the latent heat of vaporization of the refrigerant. So if the latent heat of vaporization is higher, so we will prefer that refrigerant. Why? Because the amount of refrigerant which will be needed per unit time to cool our room will be lesser. So if latent, तो कहने का भाव ये है, the latent heat of vaporization अगर ज़्यादा होगी तो हमारे रेफ्रिजरेंट की अमाउंट कम यूज़ होगी, तो हमें एडवांटेज मिलेगी। देन कंडेंसिंग प्रेशर, तो अगर कंडेंसिंग प्रेशर ज़्यादा होगा तो कंडेंसर को ज़्यादा एफर्ट करना पड़ेगा और हमें पाइपिंग भी उसी हिसाब से लगानी पड़ेगी, तो कंडेंसिंग प्रेशर शुड नॉट बी दैट मच हाई। देन फ्रीजिंग टेम्परेचर, तो अगर रेफ्रिजरेंट का फ्रीजिंग टेम्परेचर कम हो जाता है, इवेपोरेटर टेम्परेचर से, तो क्या होगा कि वो बीच में ही सॉलिडिफाई हो जाएगा. देन व्हाट विल हैपन, रेफ्रिजरेशन साइकिल विल बी ब्लॉक्ड. सो वी डोंट वांट दैट. देन क्रिटिकल टेम्परेचर. सो क्रिटिकल टेम्परेचर वो टेम्परेचर होता है जिसके ऊपर रेफ्रिजरेंट को लिक्विफाई नहीं किया जा सकता. अगर क्रिटिकल टेम्परेचर जो है, तो हमें ज़्यादा क्रिटिकल टेम्परेचर चाहिए. लेट्स से कि अगर क्रिटिकल टेम्परेचर कम है, अगर क्रिटिकल टेम्परेचर रेफ्रिजरेंट का लेट्स से 24 डिग्री सेल्सियस है, तो 24 डिग्री सेल्सियस के ऊपर तो वो वेपर में ही रहेगा. तो दैट इज द डिसएडवांटेज. वी वांट इन लिक्विड फॉर्म आल्सो, सो इट कैन नॉट बी नियर टू एम्बिएंट टेम्परेचर, इट हैज टू बी वेरी हाई. then it should be not toxic. if it is toxic then उसकी handling will be very difficult. तो flammability भी नहीं होनी चाहिए. ऐसा ना हो कि heat की वजह से उसको आग ही लग जाए. that is also not advisable. then it should not be corrosive. if it is corrosive, तो what will happen is हमारा जो material है, हमारी जो pipes है, हमारा जो equipment है जो use हो रहा है, that will get corrode. then chemical stability should be there. it should not be unstable. then it should be like, if any leak happens, so we should be able to detect, like if the leakage happens, then there should be some odor that we can detect that there is some odor and there is some leakage in the refrigeration. And then cost must also be not that much high in the process. So then what are the examples of some refrigerants? So these are the examples. So ये जो हमने नंबर्स लिखे हैं ना 12 22, तो इनके आगे आर लगा देते हैं. तो दैट इज R12 मीन्स दैट इज रेफ्रिजरेंट 12. सो रेफ्रिजरेंट 12 विल बी डाइफ्लोरोमीथेन. एंड यूजुअली आजकल ज़्यादा यूज़ क्या हो रहा है, R134A विच इज बीइंग रिप्रेजेंटेड. सो आई होप यू कैन सी. सो दिस इज R134A. सो दैट इज 1112 tetrafluoroethane. So these were some refrigerants and how we select the refrigerants. So then we have the VCRS system. So VCRS system is basically vapor compression refrigeration system. So here we will see what is VCRS system, what is its diagram, what are the components of VCRS system, and what are the advantages of VCRS system. So first of all, what it actually is. ये असल में क्लोज सिस्टम होता है जिसमें 4 स्टेप्स होते हैं. तो ऑल्टरनेटिंगली हम कंप्रेस करते हैं और एक्सपैंड करते हैं अपने रेफ्रिजरेंट को, और हम उसको लिक्विड से वेपर और वेपर से लिक्विड फॉर्म में बार बार चेंज करते रहते हैं. तो ड्यूरिंग दैट चेंज, सो वी नो, जब प्रोडक्ट चेंजेस फ्रॉम लिक्विड टू वेपर और वेपर टू लिक्विड, इट हैज लेटेंट हीट ऑफ कंडेंसेशन और लेटेंट हीट ऑफ वेपराइजेशन. So that latent heat basically absorbs or expels the heat. So that absorption and expelsion of heat is required in the refrigeration system. So on that principle this cycle works. So now we will see the diagram. So here we can see, first of all, it's evaporator. Here we have evaporator. So evaporator is basically connected to the room. So the room which we want to cool down, evaporator is connected to that. So evaporator is the one which will extract heat out of the room, and then it will heat its refrigerant, and then the further process will take place. Now we will see how actually refrigerant goes and what are basically the components of VCRS system. So we have evaporator, compressor, condenser and expansion valve. So इवेपोरेटर में क्या होता है, जो हमारा रेफ्रिजरेंट है वो वेपराइज हो जाता है इवेपोरेटर के अंदर और वो गैस में चेंज हो जाता है. तो क्या होता है, ये लिक्विड से गैस की फॉर्म में चेंज होता है. तो लेटेंट हीट का रोल वहाँ पे आएगा. तो लेटेंट हीट वो ड्रॉ कर लेता है इस शिफ्ट चेंज में, एंड वो बहुत ज़्यादा हीट एनर्जी एब्जॉर्ब करता है, और जहाँ से वो एनर्जी एब्जॉर्ब करता है वहाँ पे कूलिंग इफेक्ट आता है. तो समटाइम्स ब्राइन, ग्लाइकोल्स या इथाइलिन और प्रोपाइलिन ग्लाइकोल भी हम यूज़ करते हैं जब टेम्परेचर बहुत ज़्यादा लो होता है, क्योंकि ये क्या करते हैं, ये सोल्यूट है. So we have studied that colligative properties in chemistry, that depression in freezing point occurs. So basically if we use these, so we can even employ the refrigeration system at very low temperature. तो now हमारा रेफ्रिजरेंट जो है वो वेपर फॉर्म में आ गया है, राइट. So then from evaporator it goes to compressor. So what compressor does is, तो compressor उसको हाई टेम्परेचर और हाई प्रेशर पे ले जाता है. तो जब वो हाई टेम्परेचर और हाई प्रेशर पे लेके जाता है तो एक टेम्परेचर ग्रेडियंट वहां पे आ जाता है। तो दैट टेम्परेचर gradient will encourage heat transfer from refrigerant to ambient temperature. So this is how the temperature gradient is created so that more effectively we can have the heat transfer. So then there is some mathematical calculation also that we can calculate the piston displacement of compressor. So that is pi d square ln by 4, where d is diameter of cylinder bore in centimeters, l is length of stroke in centimeter, and n is number of cylinders. Then we can also calculate compressor displacement, that is piston displacement into revolutions per minute. So after compressor, हाई टेम्परेचर और हाई प्रेशर पे जो हमारा रेफ्रिजरेंट है वो कंडेंसर के अंदर चला जाता है. सो दिस इज हाउ कंडेंसर लुक्स लाइक. सो कंडेंसर में जैसे ही वो जाता है तो कंडेंसर के पास एक और मीडियम होता है, लेट्स से वाटर, विच यू कैन सी इन द फिगर. तो वहां से हॉट गैस आती है और वाटर को हॉट कर देती है और खुद वो कूल डाउन हो जाती है. तो देन टेम्परेचर डिक्रीजेस बट स्टिल द प्रेशर इज समवट हाई. सो बेसिकली इसका काम कंडेंसर का इतना ही है कि उसने रेफ्रिजरेंट को कूल डाउन करना है. तो रेफ्रिजरेंट जब कूल डाउन हो जाता है with some amount of pressure or with high pressure, it goes to expansion valve. So expansion valve basically maintains the flow of liquid. So here the temperature is already lowered down by condenser. It also lowers down the pressure when it again enters to the evaporator. Then evaporator में फिर low temperature और low pressure का refrigerant enter करता है. Again it turns to the vapor and again it goes to compressor, then condenser, then again expansion valve. This is how our refrigerant cycle, which is VCRS system, completed. So these were its components. Now what are the advantages of VCRS system? So it, in given refrigeration capability or capacity, it's very smaller in size. So we can get some advantage in area terms. So its cost is also very less. Once we have refrigerant there is no need to change the refrigerant or anything like that. So its cost is also very minimal. Then it has wide range of temperature conditions. So we can use it for some higher temperatures also. We can even use it for lower temperatures also by adding those glycols and propylene glycols. And its coefficient of performance is also very fair. So there is no like loss which is observed in VCRS system. And for the faster production of refrigerant we can use a refrigeration system. Uh, then we have applications. So for applications we'll see what are the methods of refrigeration, what are its application in industry, and then we will see some mathematical calculations also, and then we will see some numericals. So in methods we can even use ice refrigeration, we can go for dry ice refrigeration. So we know what is dry ice. Dry ice is basically solid carbon dioxide. We can use steam jet refrigeration, we can use throttling refrigeration, we can use liquid refrigeration, which is most commonly used, and then we can go for air refrigeration as well. So then we have what industries goes or what industries use refrigeration. So food industry definitely it uses. हम अपने घर में भी खाने को रेफ्रिजरेटर में स्टोर करके रखते हैं ताकि खाना खराब ना हो. देन डेयरी इंडस्ट्री, मिल्क, मिल्क प्रोडक्ट्स, योगर्ट, पनीर, चीज, इन सबको भी रेफ्रिजरेशन में ही स्टोर करना पड़ता है. अगेन वी नो वाई, ताकि रिएक्शन रेट कम हो सके, माइक्रोबियल अटैक कम हो सके, फ्रेशनेस मेंटेन करी जा सके. देन केमिकल्स आर आल्सो स्टोर्ड. So we might have seen on the bottles of some our lab chemicals that it should be stored in cool and dry places. Then beverage, cola drinks, and other juices are to be stored at refrigeration. And because at lower temperature the dissolution of carbon dioxide is higher according to Leach-Atliers principle. So there are many scientific principles which supports the refrigeration. So then pharmaceutical industry, definitely medicines are to be stored at lower temperature. Then we have some mathematical calculations. So for refrigeration system, for its efficiency, for its effectiveness, we need to have a mathematical approach to it. So first of all we'll see what is cooling load. So cooling load is the rate at which heat energy is removed from certain area in order to bring its temperature down to specified level and it's known as cooling load. So like with an example we can explain it, like we need to bring down its temperature to 1 डिग्री सेल्सियस, तो कितने रेट पे हमें हीट एनर्जी को रिमूव करना पड़ेगा उस पर्टिकुलर आइटम के लिए ताकि वो 1 डिग्री पे आ जाए, तो दैट रेट इज बेसिकली कूलिंग लोड. देन वी हैव कोफिशिएंट ऑफ परफॉर्मेंस. So coefficient of performance is also known as, like in other terms it is analogous to efficiency only, like how we can judge the efficiency of the refrigeration system, but efficiency term is used for heat pumps. So for refrigeration system we use coefficient of performance. So basically it is heat pumps output to the work required by considered system. So in terms of enthalpy it is H2 minus H1 upon H3 minus H2. Then we have refrigeration flow rate. So basically the entire cooling load on the system is known as refrigeration flow rate. That is M is equals to Q upon H2 minus H1. So we'll see some numerical about it, then you will be more able to understand that how these cooling load, coefficient of performance, refrigerant flow rate are calculated. So now we'll see some numericals. So first numerical. So calculate the cooling load present in walk-in chamber caused by heat evolution of 2000 kg of cabbage stored at 5 degrees Celsius. Heat evolution of cabbage is 63 watt per milligram. तो एक कोल्ड सिस्टम है हमारा, वहाँ पे 2000 kgs ऑफ कैबेज स्टोर करी गई हैं 5 डिग्री सेल्सियस पे, और हीट एवोल्यूशन जो कैबेज की है वो है 63 वाट पर mg. तो हमें कूलिंग लोड कैलकुलेट करना है. So we already studied that it is rate at which the rate which is required to bring at specific temperature. So that specific temperature over here is 5 degree Celsius. तो कितनी amount है, that is 2000 kg, और उसकी heat evolution कितनी चल रही है 63 watt per mg. तो then we'll just convert it the mg to kg and then we'll get it in watt, that is 126 watt. सो कूलिंग लोड इज 126 वॉट. सो हमें कूलिंग जो है वो 126 वॉट के रेट से प्रोवाइड करनी पड़ेगी ताकि उसका जो टेम्परेचर है वो 5 डिग्री सेल्सियस पे मेंटेन रहे. सो दैट इज द मीनिंग ऑफ दिस. नाउ वी विल सी अनदर एग्जांपल. सो बेसिकली एक कोल्ड स्टोर है दैट इज बीइंग मेंटेन्ड एट 2 डिग्री सेल्सियस एंड उसमें वेपर कंप्रेशन रेफ्रिजरेशन सिस्टम यूज हो रहा है और R134A रेफ्रिजरेंट यूज हो रहा है. सो व्हाट वाज R134A? दैट वाज 1112 टेट्राफ्लोरोइथेन, राइट. सो देन इवेपोरेटर और कंडेंसर का टेम्परेचर 5 एंड 40 डिग्रीज है. लोड जो है वो है 20 टन्स. हमें मास फ्लो रेट, पावर रिक्वायरमेंट और COP बेसिकली कैलकुलेट करना. तो ऑलमोस्ट इसमें सारे एस्पेक्ट्स कवर हो जाएंगे फॉर मैथमेटिकल कैलकुलेशन ऑफ VCRS सिस्टम. एंड देन उन्होंने कंप्रेशन की एफिशिएंसी दी हुई है कंप्रेसर की 85%. सो फर्स्ट ऑफ ऑल व्हाट वी विल सी. सो here we have pressure enthalpy chart. So here 4 points are marked. One is A, another is B, then we have C, then we have D, and then we have E. So in this order only our system is being followed. So our evaporator is at 5 degrees. So 5 degrees is at A. So subsequent pressure at A, you can see it's in bar. So it's between 2 and 3 and it's almost near to 250. So let us say it is 243 kilopascal if we convert bar into kilopascal. Then at B, which is at 40 degrees, so here it is approximately above 10. So that is 1015 something kilopascal. So here we can see the evaporator pressure and condenser pressure is given. So what is H1, H2 and H3? So now H1 is with respect to E or D. So with respect to E or D, our H1 is less than 160. So that is near 150 or something, right? Then at A, that is our H2, which is near 300 or 290 something. If you can see, here it is 240, here is 320. So with respect to A, अगर हम ऊपर तक लेके जाएं जो कि एंथैल्पी जहाँ पे रिप्रेजेंट की जाती है, तो it's near 300 or something. Then at point B, which is our H3, so here it's just above 320. So accordingly H1, H2 and H3 will come out to be 156, 296 and 327. right? So we know, right, this is for compressor, right? H1 is for compressor, right? And then H2 was basically for, if we see from this graph, so H2 basically it was for condenser, right? And then H3 is for evaporator, right? So now we know what is mass flow rate, that is Q upon H2 minus H1. So Q is basically 20 tons. So conversion factor for ton to kilojoule is 303852. And then we have H2 minus H1, and again we have here we have conversion factor so that we can convert it into seconds. So mass flow rate will come in kilogram per second, that is 0.502. Then we need to calculate the power requirement. So for power requirement, the formula is mass flow rate into H3 minus H2 upon that efficiency, right? So putting the values, we will get 18.31. Then we need to calculate COP. So COP we already saw was H2 minus H1 upon H3 minus H2. So H2 was 296, H1 was 156, then H3 was 327, and H2 again was 296. So coefficient of performance will be 4.52. So these were all the parameters to be calculated for VCRS system. So thank you everyone for spending your time with us. For any doubts, you can put in the comment section, or you can visit our website or join our WhatsApp group as well. Thank you everyone and have a nice day.